The third comment is on the soldering anomalies. Page number 5.6, class number 5.2.2, acceptable class 1 and cross indicate 2.3. This is regarding blowholes. The blowholes which are depicted in the figure, if you go by that,
what is the failure mechanism? What will this fail in operation? Why? Anybody can tell me? Even that we used to say, the criteria used to be, if you cannot see the bottom of the hole, it's a defect. NASA did some very big studies, and NASA is the space hardware in outer space, microgravity, microatmosphere conditions, big vibrations, big thermal shock, when it, in the day and night in space.
yeah, one is the blowhole depth. What about the number of blowholes? How many blowholes can be accepted in a joint? Any number? There is no restriction.
Not defined.
Mr. Jack, but Indian scenario, at least space, BEL, Bharat Electronics, Bharat Dynamics, space manufacturers, product manufacturers, their standards still say that blowholes are defective.
I am talking on behalf of Indian Space and Defense.
More to look just like this one.
Can we?
Yes. Because yeah, the bottommost, it matches with your explanation. There is a blowhole, but it's not deep enough. You don't see the bottom of the.
I am more concerned about 5.8 and 5.9.
It is difficult to say whether it is through or through or under surface. It appears as if it is a quite deep hole. Isn't it?
And I will share it with the committee. I'm going to tell you that nobody in the manufacturing in Europe.
Sudhakar, your observation was with respect to the fraying of the insulation. It is not cut vertically.
It is not cut, it is
Not cut square.
So that is the observation. So for that he has an expression. The
Committee meeting, they don't care about it. ESA doesn't use 610. ESA does like to use a lot of the J Standard 1. They've used J Standard 1 to modify.
ESA has its own standards, but they have applicable standards from IPC as a reference standard. But they have their own standards. ESA has a standard.
I hear your concerns, your defense and space, and your space and your defense space, okay? I understand 0.7 millimeters, okay? Then the other dimension for the process indicator is the farthest distance from the body. So this is showing a body at an angle. So the farthest distance would be this point right here. If it's more than 0.7, it's a process indicator. That's where the issue is. So this, if this is 0.7, this would be a process indicator condition because it's more than 0.7. But it's only a process indicator. So there's no conflict in the criteria. I don't that flush, the connector can pull out part way and won't be flush. It may be able to move up and down in there, and that'll create intermittent connections. Okay? So the acceptable is flush, or not more than 0.75. Okay? Target condition would be flush. But we already say acceptable is flush to 0.75.
But as per the IPC, they have only given the 0.75 mm below the connector face. There is no terminal. So my point is this.
Oh, there is tolerance. The tolerance is from flush to 0.75.
No, there is no definition for that.
Yes, there is.
It
Says the jack post face is flush to 0.75. So it's either from flush or down to 0.75. That's the tolerance. The tolerance is 0.75 millimeters.
So the word is two. Flush two.
Flush to.
is equal to connector face.
Right. From flush down to point. Right.
Yeah, yeah. Okay.
Okay, so that's the tolerance. Okay?
Okay.
Next one.
Solder knowledge, exposed versus metal. So here in class, defect class 1, 2 and 3 is not defined properly, because as per the defect class 1, 2, 3, expose this metal on component and lead, conductors or land surface from nicks, scratches or other conditions exceed the requirements. Reference clause 7.1.3 explanation is not given with the details, because if we refer the 7.1.23 and 10.3.1, this is only on define the conductor and land reduction in the cross-sectional area, means that is related to damaged area.
Solder charges. Then the next two rows will have the solder charges on the inside. So this is what it looks like when it's being placed on the assembly. Okay? Now, the requirement for this is no side overhang. So we have some pictures showing no side overhang, but it's no side overhang of the terminal, not of the solder slug. The criteria is always only for the terminal. Okay? So here we see that the terminal is centered right over the land. By the way, the components, these devices that are made by Samtec have a single hole in them with a solder slug in it. The ones made by Molex have two holes in it, okay? And they require an oval land for proper solder connection, okay? It's all in the design criteria. Here you can see a whole strip of these things, okay? Criteria in 610, J1, is showing here is the terminal, here is the solder charge, here is the thing. So now we mix together then the criteria. Maximum side overhang. For target condition, no side overhang. For modified through-hole leads, okay, that's defined as these cut off dip leads, is 25%. For solder charge terminations, 0 side overhang. No side overhang is acceptable. We have the pictures to show that. Defect. For my modified through-hole leads, does not exceed 25%. I don't have a picture, okay? For the solder charge, so here is the termination, and it's overhanging the side. As you have 50 thousandths of solder of any place, from the top down to the middle, down to the bottom, on there, it will pass all the reliability testing you can use for classes 1 and 2. Not for class 3. Class 3 says 75% fill. Okay? Now, 50 thousandths. Whoa, how much is 50 thousandths?